Firstly, let's see the introduction. Torsion testing is a type of mechanical testing that evaluates the properties of materials or devices while under stress from angular displacement. Torsion testing also can be split into two distinct categories, which are testing raw materials like metal wire or plastic tubing. Torsion test is to determine properties such as shear strength and modulus for functional testing of finished products subjected to torsion, such as screws, pharmaceutical bottles, and scratch cable. The most common mechanical properties measured by torsion testing are modulus of elasticity in shear, yield shear strength, ultimate shear strength, modulus of rupture in shear, and ductility.
Hi, I'm Nazira and I will proceed with the objective of the project. The first one is to analyze the force of members and draw the details of free body diagram from the actual structure. The second one is to develop equilibrium equation from the free body diagram drawn. The third one is to calculate the torsional shear stress subjected to the torsional loading. And lastly is to determine the value of torsional force that will fail the structure.
Hello and very good afternoon. My name is Lokman Nur Hakim bin Jamil. Today I will present about the data of structure. We pick the doorknob lever type as our model to discuss about the torsional of this assignment. Material properties of shear for this part is made from aluminium. The yield strength we assume that 110 megapascal. For the shear modulus G equal to 76 gigapascal. For the next slide, I will show about the detail of free body diagram that we can determine the equation of equilibrium EOE, torsional shear stress, and angle of twist. The detail of this free body diagram will go through about for the calculation. And for the force for FE, we assume that 90 Newton. For the next slide, I will pass to my friends about the calculation. Thank you.
Now let's proceed to the calculation. Firstly is the equation of equilibrium. Summation Fy is equal to 0. F1 minus Fe equals to 0. Fe is equal to negative 90 Newton since Fe is in downward direction. Then F1 will equal to 90 Newton. Next, we will find the torque. We will be using moment to find the torque. Then moment is equal to 0. Torque minus 90 Newton times 0.14 meter is equal to 0. 0.14 meter is the length of the door handle, then torque will equal to 12.6 Newton meter. Next, the torsional shear stress. J is equal to polar moment of inertia and C is the radius. J equal to pi over 2 times C power of 4. Our C is equal to 0.01, hence J will equal to 1.57 times 10 power of negative 8. And the internal torque will get 18 Newton meter by torque plus 0.06 times 90 Newton. Lastly is the angle of twist. We will use torque times length divided polar moment of inertia times shear modulus, and the angle of twist will be 1.48 times 10 power of negative 3 radian. Torque max equal to internal torque times radius divided to polar moment of inertia. Then 18 times 0.01 divided to 1.57 times 10 power of negative 8. The answer will be 11.5 megapascal. To calculate the maximum shear stress, we will use the torque times radius divided by moment of inertia. Then 12.6 times 0.01 divided by 1.57 times 10 power of negative 8 and equal to 8.03 megapascal.
Next, we will continue with the discussion. Firstly, the factor of safety expresses the strength of a system than how much it is required to be for an intended load. It is a form of reliability encountered to produce a design structure. For this product, a basic equation to calculate factor of safety is by dividing the maximum stress over the working stress as shown. Hence, the value of factor of safety of this product should not exceed the range of 1.4 megapascal. This is to ensure that the product is safe to be used in its working condition. Then, to calculate the maximum torsional force failing the structure, it can be determined by using the formula force equals torque times radius divided by J, and it is resulted to 1805.5 Newton. If it is exerted to the structure, it will fail like losing or broken. So now we know that the magnitude of the torque depends on the applied force and the radius between the lever arm. So the larger the force applied, the torque will increase. Therefore, we assume that the applied force can result to zero torque if there is no lever arm or the applied force parallel to the lever arm.
Hello, my name is Lokman Hakim bin Amran, and I will talk about conclusion. From the project that we conduct, we can analyze the force member from the structure by drawing the free body diagram or FBD of that object that had been chosen, that is doorknob. Besides that, we also able to show the calculation of the torsional shear stress subjected to torsional loading using the equation of equilibrium. Lastly, to conclude our project, we able determine the maximum torsional force that will fail the structure, which is 8.03 megapascal. That's all from me. Thank you.